Did you know that you are made up of mostly empty space? That is not meant to be an insult, more of an example of how you are made up of atoms, and most of the volume of an atom is completely empty space. An atom is the smallest particle of an element that still has the same properties of that element. Remember that an element is a pure substance made up of only one type of atom. Thomson, Rutherford, and Millikan, all scientists, discovered that atoms were made up of even smaller particles called subatomic particles. This lesson is going to focus on the three main subatomic particles: the proton, neutron, and electron. As we move through this lesson, I would highly recommend having a periodic table in front of you as a reference. The periodic table is an organized reference of all the known elements arranged according to their properties. You will almost always have access to one of these, so it would be a good idea to learn how to use it. Protons are probably one of the single most important parts of an atom. The number of protons an atom has determines what type of element it is. For example, all elements that have only one proton are going to be atoms of hydrogen. Find hydrogen at the top left side of your periodic table. You should notice a few things about this box. First, it may have a large H printed in it. This is the chemical symbol for hydrogen. Each element has a different chemical symbol. You should also notice that the number 1 is prominently displayed in this box. This indicates the number of protons that atom will have. You may notice quickly that this number is increasing by 1 as you move from left to right and top to bottom on the periodic table. So helium has the number 2 in its box, lithium has the number 3, and so on. This means that all atoms of helium will have 2 protons, and all atoms of lithium will have 3 protons. The number of protons is called the atomic number, and it is really special because it gives the atom its identity. Keep in mind that not all periodic tables are exactly the same, so some may have the atomic number for each element in a different location. Another interesting feature of the proton is that it carries an electrical charge of +1. Don't worry about the units of this charge, just remember that it has a charge of +1. Protons are also relatively heavy. They have a mass of about 1 AMU, or atomic mass unit. Because atoms are so tiny, they require a different type of unit to measure their mass. We will be using the atomic mass unit, or AMU, when we discuss the masses of atoms and molecules. The final feature of a proton is that it is tucked away inside the nucleus of the atom. The nucleus is the very tiny, dense region in the center of an atom. The nucleus is so tiny that if the nucleus were the size of a basketball, the rest of the atom would be the size of a large city. One thing that gets a little confusing is that the word nucleus can mean many different things, depending on which branch of science you are in. In chemistry, the word nucleus refers to the nucleus, or center, of an atom. In biology, the word nucleus refers to the nucleus of a cell. To give you a visual idea of the difference between an atom and a cell, there are trillions upon trillions of atoms that make up each living cell. And atoms are not living. They are the building blocks of everything. The next particle inside the atom is called the neutron. Just like protons, neutrons are located inside the nucleus of an atom. Neutrons also have a mass of about 1 AMU. So protons and neutrons are both located inside the nucleus, and they both have a mass of about 1 AMU. Unlike protons, however, neutrons do not carry an electrical charge. They are neutral particles. This should be very easy to remember because the words neutron and neutral are so similar. Remember that all atoms of the same element have the same number of protons. Does this mean that they have the same number of neutrons? Nope. Atoms of the same element can have different numbers of neutrons. These atoms with the same number of protons but different numbers of neutrons are called isotopes. Think of isotopes like siblings. They are related, but they have some differences. For example, all carbon isotopes have the same number of protons, 6. However, some carbon atoms are going to have 6 neutrons. Some will have 7, and some will have 8 neutrons. These isotopes will all chemically react the same way, but they will have differences in their nuclear stability, which means that some will be able to undergo a nuclear reaction more easily than others. This is because they all have different amounts of neutrons in their nucleus. So how do we tell the difference between the different isotopes of carbon? For this, we will use nuclear symbols. The letters in a nuclear symbol represent the element. Recall that each element has its own abbreviation. In this example, we have a C, which is the chemical symbol for carbon. The numbers tell us what is located inside the nucleus. The number on the lower left of the symbol is the atomic number, or the number of protons. You will also notice that all of these have the same atomic number, because they all are carbon atoms. The top number equals the number of protons plus the number of neutrons. This is called the mass number. So on the first one, the mass number is 12, indicating that the total number of protons plus neutrons is 12. Below that is the number 6, which is just the number of protons. So how many neutrons does this atom have? If you answered 6, you are correct. You can find the number of neutrons by subtracting the top number minus the bottom number. Try the next one. How many neutrons does this carbon atom have? This one has 7, and the next one has 8. In this example, the carbon with 8 neutrons has the most unstable nucleus. This is the isotope that's used in carbon dating to estimate how old an ancient artifact is. The last particle on our journey inside the atom is the electron. Electrons are very different from protons and neutrons. First of all, they are not located inside the nucleus. They're found in a very large electron cloud outside the nucleus. Remember, if the nucleus were the size of a basketball, the rest of the atom would be the size of a city. As you can see, the electrons have a very large space to move around in. However, because they are so small, most of this large space is completely empty. That's why you are made up of mostly empty space. Later on, we will also find that these speedy little guys play a key role in determining the chemical properties of an atom. Also, every electron carries a -1 charge. This is exactly equal and opposite to the charge of a proton. So 1 proton and 1 electron would completely cancel out in charge. Atoms are electrically neutral, which means that they will have the same number of protons and electrons. So back to our carbon atom. It has 6 protons, so it also must have 6 electrons. Another feature of the electron that makes it so much different from the proton and the neutron is that electrons have almost no mass. In fact, the mass of an electron is so much smaller than the mass of both protons and neutrons that in this course we are going to ignore the mass of electrons. Each of the 3 subatomic particles has its own personality. Protons are positive, heavy, with a mass of 1 AMU, and located inside the nucleus. They are responsible for determining the identity of the atom. Neutrons are electrically neutral. They also have a mass of 1 AMU, and they're also located inside the nucleus. Electrons have a negative charge, have almost no mass, and are located in a very large region outside of the nucleus called the electron cloud. Atoms are electrically neutral, meaning that they have the same number of protons and electrons.